All right, everybody, we're at the top of the hour. Let's get started. So today we're going to talk about how we can get from sources to insights in seconds and what a modern real-time analytical data set that's simple and performant looks like. Before we start, I quickly want to go through a quick round of introduction for our speakers and presenters for today. I am Kevin Shen. I am a principal product manager at VeloDB. Excited to kind of kick us off today. And we have two very exciting presenters from Supermetal. Please introduce yourself.
Hi everyone, I'm Shabam. I'm co-founder and CEO at Supermetal. And yeah, really excited to show you Supermetal and VeloDB in action today.
Hey everyone, I'm Vasif, co-founder, CTO at Supermetal. Excited to show you guys the demo. Yeah.
Thank you. So before we start, just to kind of lay a little bit of context, a lot of this is really coming from feedback from user group. But as VeloDB and Apache Doors community, we are a real-time and search analytical database. And because we're real time, we need to make sure things are real time from end to end. So many of our customers come to us with pain about getting data into VeloDB from their source systems, such as transactions. And one of the main things that people complain about is the CDC tax. It is complicated, heavy, involves multiple hops and components. And when we look at this diagram, oftentimes people spend more times managing the pipeline than either the source and sync systems. Some of the common challenges that really keep folks up at night include things like operational surfaces. Bringing in CDC sometimes means just as many components as your actually source and target databases. And each component that you bring in adds to the latency and slows down the ability to be real time, lengthens the data freshness, and so forth. And finally, one of the challenges in this area is also that as we're dealing with data that's rapidly changing, evolving, especially with modern systems where there are new dimensions and new fields being added all the time. These schema evolutions often break pipelines and requires human intervention, really adding to the operational hurdles. Plus, additionally, that a lot of these surfaces needs to be kept on 24/7, make it so that it's not only an operational challenge, but also a cost challenge. And of course, we oftentimes leads to the pattern of seeing just multiple FTEs spending often months just getting all of these pipelines ready and then maintaining things so that they are stable. To add a little bit more color to this challenge, we want to kind of just bring it to two patterns that we see. One in a e-commerce data team, so think about things like B2C, ad targeting. We're dealing with heavy transactions. Replica can fail behind, and you can often spend a lot of times trying to recover, and it basically stops your analytics in its track. On the other hand, when we look at a B2B setting, maybe we're looking at events, maybe we're looking at internal job, external jobs. Schema evolution often breaks things down, and they spend month troubleshooting to make sure that things are actually stable. So, with all that being said, I don't want to spend too much time because we all know about the pains of a broken pipeline, but there is an easier way. And that's where Supermetal comes in, a leaner, faster path forward with CDC. So I'm going to hand it off to Shubham to take us through the rest of the presentations.
Hello everyone. Hope everyone can see my screen. Cool, awesome. Yeah, so happy to chat about CDC that just works because that's the experience we're looking for. And yeah, that's what we built Supermetal for. So to tell you a little bit about us, founded in 2023, so we're a new CDC company, a new CDC product. We were backed by top tier investors. A creator of Apache Arrow is also an investor in our company. Supermetal is built by database and system engineers from the ground up. My co-founder, CTO Wasif, spent a lot of time working on an internal transactional database at AWS that powers most major public products at AWS. And today, Supermetal supports CDC from all major transactional databases to targets like VeloDB, ClickHouse, Snowflake, Databricks, Kafka, and even Apache Iceberg. We are moving 50 terabytes plus data every month, and that's aggressively growing. We very, very frequently match replication throughput up to a terabyte per hour, which is significantly higher than what you would get from other products. And we mostly currently work with enterprises and enterprise deployments. To kind of give you the lay of the land for the sources that we cover, so you can see we very extensively covered all major transactional database sources. So you have Postgres, MySQL, MongoDB, SQL Server, Oracle, and even a file source that helps you sync data from, Parquet files, JSON files, CSV files directly to a target like VeloDB. So to kind of give you, what really differentiates Supermetal from an architecture perspective, I think we have all seen what the traditional CDC stack looks like. So you've got your source database. You need something like Debezium or Flink CDC. You obviously need at least a 3+ node Kafka cluster. And you may have more, transformations on the consumer side before the data actually lands in VeloDB. So that's what your, typical pipeline looks like. And we can see there are multiple components here. It can take weeks to deploy, and the infrastructure itself is very difficult to manage because of the number of parts. Enter Supermetal. So Supermetal is built from the ground up in Rust. It ships a single Rust binary. It's also built using Apache Arrow, so that gives us very accurate data type mappings, very accurate schema evolution. So things like if you change your, if you add a new column on your source database, or if all the data type on your source database, Supermetal automatically propagates that all the way to the target. You don't have to worry about manually changing and fixing things. The other advantage of using Supermetal, especially in the VeloDB pipeline, is we heavily leverage object storage. This allows us to push data Parquet files to object storage, and we're able to leverage VeloDB's table value functions, TVFs, to directly pull data. And this overall leads to a much, much efficient and higher throughput pipeline. And so if you really look at what you're getting out of Supermetal, Supermetal ships as a single binary, so it helps you deploy on any environment. You can run it on your laptop, you can run it on-prem, you can run it on cloud, and it gives us a lot of deployment flexibility from that perspective. It also lowers your total cost of ownership and ops because you have less components to manage. And Supermetal can vertically scale with the number of cores that you have on the machine. So you can keep scaling Supermetal if you wanted to on a single machine. And you can no limits on the number of connectors you can run, or no limits on the volume of data that you need to sync. So how do we compare how much faster is Supermetal compared to other vendors? So when we benchmarked ourselves, we found we were up to 7x faster than other vendors like Airbyte and Fivetran. Obviously, like the other problem with Airbyte and Fivetran is that they're not really real time. And so Supermetal gives you very, very fast snapshot performance because we use something called parallel snapshots, where we're able to parallelize the workload on the source database all the way to the target. And that's what helps us achieve this much faster throughput. Of course, we provide very low latency real time. We allow our customers, users to really tune what level of latency they want, and Supermetal is able to support that. In addition to all of this, we save companies a lot of money because Supermetal deploys directly inside your infrastructure. We're not charging you by the number of rows you're syncing or the volume of data you're syncing, which is what Fivetran and Airbyte do. And Supermetal's pricing starts at 10K per year. So if you're running a single Supermetal agent, let's say on an EC2 instance, you're just paying us 10K per year for that, and we're not charging you on volume or the number of rows you're syncing. We are quite proven in production. We did a very, very large Postgres to Postgres migration for a Web3 company called GoldSky. We migrated 30 terabytes of data for them. In addition to that, we're also currently in multiple production pilots, working on multiple use cases, working on an Iceberg use case right now where a customer is syncing CDC from Postgres, MySQL, MongoDB, SQL Server to Iceberg. And they're trying to actually eliminate both Fivetran and Snowflake by using Supermetal. So very massive cost savings there. We're also being used by a very large global data analytics company for a SQL Server CDC use case. Similarly, we're also in late stage pilot with the Fortune 50 company for a SQL Server CDC use case. Cool. A lot about Supermetal. Happy to actually show you Supermetal in action. So over to my co-founder, CTO Wasif. And yeah, I'll just take you from there.
Hey, so let's quickly log into my AWS account here. We're going to start from scratch all the way. I can click connect. Single command and specify the server flag. This starts up starts up Supermetal with UI built in. Quick password to encrypt credentials. Supermetal has started on port 3000. I can go back to my instances here, copy the IP address, and type 3000 here. All right, we're ready to create a simple RDS Postgres to VeloDB integration. So I'm going to go here and click New Connection, select Postgres as source. Let's rename it PG VeloDB, and for host, let me. So I have like temporary credentials provisioned, which are all going to be reset pretty soon. So I'll just start copying them here. This should be Postgres. Password is the one we just copied. Database is also Postgres. For the replication type, we're going to pick logical replication, but we also support like multiple different replications types, like snapshot only replication if you just want to sync like that data one time, and more advanced security options. But let's go ahead and test the connection. Everything works. We're connected to Postgres 18.3. Let's move forward here. In the catalog, I can see a bunch of tables. So this is TPCH data of like scale factor of 5. So that means this database has around 43 million rows. Standard TPCH tables. We're going to sync everything. So let's move forward. On the target side, I'm going to pick VeloDB here. So let's enter the VeloDB URL. We just provisioned the instance there. Username. Okay, target database name. Let's see. Let's create it as Supermetal. This should be admin. Password. We're going to reduce the snapshot concurrency here since this is a test cluster, and run connection test. So everything passes. We got the server information back. Let's go ahead. Since Supermetal is designed around like object store, we're going to pick AWS S3 as our intermediate buffer. I'm going to pick a bucket that I pre-provisioned in US S2 cluster. Run a bunch of tasks. Everything passes. We have read-write permissions to that bucket. Now we can like actually create the connector. So what happens at this point in time is like we just send a bunch of partition queries to Postgres and immediately start syncing each Postgres partition. So you can see the row throughput here is pulling around 4 to 5 millions of rows per second. Actually, this is our actual row input throughput. So we're reading let's say about 5 to 6 million rows per second. Query them, let's wait for the snapshot to finish, and then we'll run a real-time workload through this connector. Okay, looks like snapshot. So it should stabilize in just a moment. Okay, we're starting to pick up the transactions in real time. And everything gets passed to Parquet files, gets written to object store, which VeloDB is pulling from. So yeah, that's the quick demo. Here's the latency we're holding. This shows like total end-to-end latency P100 of 6 seconds. This is 6 seconds because our buffer interval is configured to like 5 seconds. If you go here, actually, yeah, okay, we don't have the option to see the latency configured here, but yeah, we're buffering transactions from Postgres up to 5 seconds. That's where the latency comes from. And the additional 1 second is the actual write latency to like a VeloDB. So yeah, that's like an end-to-end real-time pipeline. Yeah, about 30 million rows. This is like the count is a bit approximate, but yeah. So there you go. That was a very quick demo of syncing data from Postgres to VeloDB in real time. Before we move forward, do we have any questions?
Yep, and I'm going to allow everybody to talk. I see there's one hand raised from David. Feel free to come off mute.
Yeah, so my question basically is I think what you have seen is just basically based off on CDC, and that means that we have like a primary key that we are tracking the data against. So let's say now for situations like where we have like large tables and we don't have like a primary key that we can track the data against. Um, uh, how do you approach that?
So we handle tables with our primary key in two ways. Our current approach is to like append to target tables. That means we tag all your tables with two metadata columns. One is the version column that represents the source timestamp where the transaction committed at the source. The second metadata column is a deleted column. Using those two columns, you can figure out which row is the latest one. Soon, we're adding another primary key mode, which actually dereplicates data when it writes to VeloDB tables. So that means like your target table without primary keys will actually represent the current state in your source database. Does that make sense?
Yeah, it does. And I think maybe a follow-up that would be now that we have like we're interacting with the source system, are we going through the transaction log or are we selecting like individual tables?
Okay, got it. Yeah, our approach is like pretty similar to what Fiveprint does. Fiveprint handles like for tables with no primary keys, they hash the entire row and generate a synthetic surrogate primary key, which is a hash of all the columns in the for that particular row. So that way we detect like if a prior row that we synced got changed, and we mark it, we soft delete that row.
All right, okay.
All right. If there's no other questions, here's some information about where to find out more. I'm going to quickly share a few links. So if you're interested, if you're interested in learning more about Apache Doors, VeloDB, or Supermetal, here are some helpful links for you to take note of. Whether you want to get started with Supermetal, with VeloDB, super quick. It's a one-click sign up with VeloDB Cloud, and also with Supermetal, super easy to get started. It's a single curl command to get everything installed. So again, really want to emphasize that CDC does not have to be difficult, and with a lot of the new developments that we see, could be super straightforward and really help to accelerate your journey to analytics. All right. If there are no other questions, thank you everybody for joining for the webinar for today. The slides and the recordings will be shared, so keep an eye out for that if you weren't able to make it in live today. Thanks, everybody.
Thanks, everyone. Really appreciate it.
Yeah, see you
All right,
guys.
thank you.